Hello, welcome back to my channel, and I'm your Nimsha Davies. And this will be a DSA with Java series, complete DSA series, in which you can understand from beginner to advanced level of data structures and algorithm. Okay, so let's get started. Before that, if you are new to this channel, don't forget to subscribe my channel and also enable the notification bell. One second, let me share the screen first. So once again, welcome to day one of our data structures and algorithm in Java course. And in this video, we will understand what DSA actually means and the type of data structures, where they are used in the real life, and how they are different from the data types. So let's get started. And by end of this session, you will have a clear idea of why data structures and algorithm is considered in the heart of computer science. Okay. So what exactly is DSA? DSA stands for Data Structures and Algorithms. It's one of the most fundamental concepts in the programming. So let's break it down. Data structures. They are the ways to organize and to store the data in the memory so that it can be used efficiently. Data structure means we are storing or we are organizing the data in the memory so that we can use them later. Okay. So what is algorithm? Algorithms are the step-by-step methods or logical procedures that operate on that data to solve the problems. So there are two words, data structures and another one is algorithm. So data structure mean we are it's a way of organizing and storing the data in the memory so that we can use it later, and algorithm is the step by step method or procedure to operate on that data to solve the problems. Okay, so together, DSA, data structures and algorithm, helps us to write programs that are fast, optimized, and scalable. So let me give you a simple example. Suppose you're building a school management system and you need to store 1,000 students' name. Okay, so you could use an array, right? If you know the number of students in advance, you can use array, or you can use linked list. If you will be adding or removing students frequently, you can use linked list. Or if you need to search quickly by the student ID, you can use hash table, right? So the point is, different problem needs different data structures. So choosing the right one can make your program much faster and much efficient. Got it? So you might be wondering why is DSA is important? Why we need to learn data structures and algorithm, right? So the number one point is it helps you to write efficient code or efficient programming. You will learn how to use less time and less memory. Number two, it improves problem solving skills. You will start thinking logically, step by step. And number three, data structures and algorithm is the core of technical interviews. Almost every top companies or MNC companies like Google, Amazon, Wipro, Infosys, TCS, they test your understanding of DSA, right? If you have experience in attending MNC interviews, you already know that most of the company, not most of the company, all the companies will ask the question from DSA, right? And finally, DSA is the foundation of computer science. It's used everywhere in operating system, databases, AI, and even in networking. So, data structures and algorithm is very, very important in our tech field. Okay. Now, let's define what a data structure actually is. A data structure is basically a way to organize the data so that it can be accessed and modified efficiently. Think of it like a toolbox. You had different tools for different tasks. a hammer for nails, or a screwdriver for screws, right? So, similarly, in programming, you use different data structures for different types of problem. For example, an array is great for indexing, or a stack, it's good for undo operations, and a queue, it helps in scheduling the task. So, we can use different data structures for different types of problems. That's the main point. Okay, coming to the classification of data structures or type of data structure. Data structures are generally classified into two main types. The first one is primitive data structure. These are the basic built-in types like integer, floats, characters, and boolean. And the second one is non-primitive data structure, which are more complex, and it can hold multiple values. This includes arrays, stacks, queue, linked list, trees, and graphs. So let's understand them one by one. Okay, primitive data structures. It's are the simplest and the fundamental ones. For example, here int in this integer, it is used to store the whole numbers, and float, it is for the decimal numbers. Char, it for the single character. Boolean, it for true or false values. So these are the building block for all other types of the data structure. Okay. Now let's talk about non-primitive data structure. These are two types, linear and non-linear. Data structure is divided into two, primitive and non-primitive. And non-primitive data structure is again divided into two categories, that is linear data structure and non-linear data structure. And in linear data structure, the elements are arranged one after the another like a line. For example, arrays, stack, queues, and linked list. Okay. And in nonlinear data structure, the data is connected in a hierarchical or in a network fashion. For example, trees and graph. Fine. So let's look at linear data structure in detail. First one, array. It stores elements in a continuous memory. It's best for the indexing purpose. Array is best for the indexing purpose. Just note those points. Fine. And the second one is stack. It follows LIFO, last in first out, like undo operation in the editor. Okay. And the queues follows FIFO, first in first out, like a line in a ticket counter. Okay. And the next one is linked list. It consists of nodes connected by the pointers, which is ideal when you frequently add or remove the items. Okay, so each of these data structures has its own strength, and we will explore all of them with the Java implementation in the upcoming videos. Okay, we will go in depth of each of this topic. Fine. Okay, so coming to non-linear data structure, they are used when the data needs to represent hierarchy or in a relationship manner. So the examples for the nonlinear data structures are trees and graph. Trees represent the hierarchical data structure or hierarchical data. For example, your computer folder structure, it's like a tree, right? And in the graph, it represents the relationships among the nodes, like a network of friends in a social media or routes in Google Maps. Okay, so these data structures are very, very powerful and widely used in the real world applications. And sorry, now let's move on to the second part, that is algorithms. And algorithms is simply a step by step procedure or process to solve a specific problem. What is an algorithm? It's a step by step process to solve a specific problem. For example, to search For a number in an array, you can use the linear search algorithm, which checks each and every elements one by one, right? Or you can use a binary search algorithm, which divides the array and checks the middle element, making it much faster. So, even though both do the same task, one is more efficient than the another. That's what makes algorithms so important. A good algorithm has five main characteristics. One, it should accept the input. It should give at least one output. Third, each step must be clear and unambiguous. Fourth, it should always finish after a finite number of steps. Okay, and the fifth one is steps should be simple enough to execute easily. Come again. First one is it should accept the inputs. Second one, it should give at least one output. Third one, each step must be clear and unambiguous. Fourth one, it should always finish after a finite number of steps. And the fifth one is steps should be simple enough to execute easily. If any of these steps are missing, your algorithm might be fail and run forever. Okay, it will continue the execution. Okay, it won't stop, or maybe they will fail. It depends. Fine. Now, let's understand the difference between data types and the data structures. Both are similar words, right? Not similar. Maybe a few students will misunderstood both are same. So a data type defined what kind of data a variable can hold, like int, float, or char. And in data structure, on the other hand, it defines how that data is stored and managed, like array, stack, and trees. So you can think of data type as individual building blocks, while the data structures are the blueprint of how you organize these blocks. Okay, fine. So coming to the real world application of data structures. Data structures are not just theory part. In most cases, we learned so many theories in data structure, right? We have to implement those things. So, the main thing that you must need the basic understanding of Java programming. Okay, in this course, we are using data structures with Java. Okay, so data structures are everywhere in the real world or in real life. The stack, it is used in your browser for back and forward navigation. And the queues, they are used in task scheduling by the operating system. The trees, they are used in file system, databases, and even in compilers. And the graph, they are used in Google Maps, social media connection, and web page ranking also. And the hash tables, they are used in caching and the database indexing and even in the symbol tables. So, whenever you use your phone or browse a website or even use any apps, the data structures are working behind those scenes. Okay, so let's summarize what we learned today. DSA stands for Data Structures and Algorithms. And the data structures help organizing the data. The algorithm defines the steps to process that data. Okay, so choosing the right data structures will improve the efficiency, which leads to better performance. Okay, so DSA is the foundation of the programming and it is very, very important for your interviews. Okay, in short, DSA makes you a better problem solver and a better programmer. Before we wrap up, just try to answer these questions. What is DSA? Just define DSA in your own words, okay? And also just give two real world application of data structures. And what's the difference between an array and a linked list? Just Google it, or you can use ChatGPT or anything. Just give an answer for these three questions on the comment section below. Okay? And I'll reply to all of the comments personally. Fine. And that's all for today. And in the next video, we will learn about algorithms, their types, characteristics, and how to write the pseudocode in Java. Yeah, that's all. And don't forget to like, share, and subscribe for more DSA lessons. See you in the next class. Bye. Have a nice day.